Today starts our new section, 1.3 Domain Restrictions. What does it mean to restrict something in the real, like in life? What does it mean to have a restriction? A limit? Yes, exactly. You're restricting something. But first let's establish what we know about linear and quadratic functions. So here I have an increasing line and here I have a decreasing line. If I came in from the left and the right, what's my domain of this first line? Give me both pieces, not just one. Negative infinity to infinity. Does anybody remember that other symbol we could write? Kind of like that funky R. That means all real numbers. Raise your hand if you've seen that symbol before. One person? Alright, let's learn how to draw it together. It means the same. So what we draw is two vertical lines like so. 1, 2, side by side. And then finish making an R. That means all real numbers. And it means the same as negative infinity to infinity. Yes. As of today, this and this are interchangeable. So now I have a decreasing line. What's the domain of this decreasing line? Reverse that. Same thing. So either put that or put all real numbers. Your choice. Two straight lines like that. Look. Two straight lines. Like that. Side by side. And then make an R. Now, challenge. Can you draw a straight line that has a restriction? So I gave you an example of an increasing line and an example of a decreasing line. Is it possible to draw some kind of line that will have a restriction? No open or closed circles allowed. Can you draw it? Just asking, is it possible to draw a straight line that has a restriction? What would it look like? No? No, see here? Note, no open or closed circles, so we can't add open circles to it. Say it again? Yeah, so no, not possible. It is not possible to draw any kind of straight line and have there be a restriction. And we can draw a conclusion from this. What's my general formula for linear functions? F of x equals mx plus b. What's our conclusion for all linear functions? What's my domain? Always. No matter what kind of line. Increasing, decreasing, doesn't matter. What's my domain? All real numbers. Negative infinity to infinity. Or all real numbers. No restrictions. So we're working with our highlighters. This would be great to have it stand out. Linear functions that look like this. No restrictions. Next, what is this shape called? Starts with a Q. What is this called? Close. Try again. He was on the right track. How do you say it? What is this shape called? It's a U, but in math, starts with a Q. There you go. Quadratics. So now we're going to look at quadratics. Oh, I'm sorry. These cover with this. Sometimes it's hard for me to hear. Here I have a quadratic that opens up, and here's one that opens down. Can I have the domain of both of these, please? Brittany? I come in from the left, I hit negative infinity. I come in from the right, infinity. So you could either write that out, or what else could you now say? What's that called again? All real numbers. Now this one's opening down. Maybe that changes things. Let's see. I come in from the left, still what? And I come in from the right, still infinity. Or also this is called, 3 words, all real numbers. Challenge number 2. Can you draw a U-shape, these quadratics, that has a restriction on the domain? If we were looking range, my range does have a restriction, right? The range is what Cabral was taking a look at. The range would be negative 5 to infinity. That's the range. So yes, the range does have a restriction, but will the domain, when I look left to right, can I ever get a restriction here? No. So, from Algebra 1, does anybody remember our general formula for quadratics? I'll start you off. F of x equals ax squared plus bx plus c. Let's highlight that. So all quadratic functions, what's our conclusion? What's the domain for all quadratics? No restrictions. So we have 2 solid examples. No restrictions. We're going to keep these in mind. Before we do that, let's make sure we're all on the same page with vocab. Look at the back. This is going to take us 20 seconds tops. Check out the back. All 3 of these are different. How is this one different from this one? Arrows. How many arrows? Arrows on both ends. Arrows on both ends makes this a what? What's this called? True, think even more simple than that. Starts with an L. A line. That's a line. What's different about this one? Closed circle and arrow on how many ends? Arrow on only one end. This one's called it's a 3-letter word that starts with an R. There we go. Ray. And do we have any arrows here? Very good. No arrows. Line segment. Piece of a line. How about that? Very good. These are they going to be the same? We can't just add arrows to that. So it's kind of implied that we have closed circles on each end. So this would also be line segment. Okay, we have our vocabulary set. People who are all set, this was just a quick little warm-up and a reference for those 2 functions. We have our notes for today. Can I have passers, please? Notes, and then the homework is attached, so that's nice. We're officially ready to start our discovery. Can I have a passer for this side? As you get your copy, check out the question in this box up top. For each of these root or radical function graphs, can you figure out what x values the graph seems to be avoiding and what connection is there to its equation? Interesting. So here's the graph, and then each of these, the equation is written right above. Can we make some connections? Thank you. So let's talk domain of this first function. What are we thinking there for the domain? Is it all real numbers? This first one? I come in from the left. Do I hit an arrow? No, so it's definitely not going to be all real numbers. Where am I starting? 0 to what? Infinity. Do we see any connection to here yet? Maybe not. Remember, this is discovery. Anything yet? Not yet? Okay. Well, let's look over here. What's the domain of this one? Negative. This one does not have a restriction. Interesting. Or all real numbers. Make yourself a note. Which one of these had a restriction? Yeah, this one on the left. Now, if I take a closer look, you can hold up the paper a little closer because you can see. What's the difference between this radical sign and this radical sign? Do you see a difference? This one is squared and this one has a what? Very good. The even root because 2 is even. We agree on that? Did the odd root have a restriction? No, so we have another one that does not. So let's make a note. Odd root functions. All real numbers. Odd roots, all real numbers. Even roots, we have restrictions. Let's keep our discovery going. The question still stands. What is this graph avoiding? Like, where do I not have x values? Or, where's my first x value? -5 to what? What happens if I were to plug in this -5 for x? Let's try that. What is f of -5? What would I have underneath the root? -5 plus 5 equals the square root of 0. Does that exist? What's the square root of 0? 0. That exists. Give me a number to the left where I do not have the graph. You want to try -15? Yeah, that's over here somewhere. So that would be what underneath the radical? -15 plus 5 would be the square root of what number? -10. Can I do that? Why not? True. The fact that she said that -10 is multiplied to get two different numbers, meaning it's not a perfect square. That's true. That's not the reason why I can't take the square root of this. Think back to last year. What can you not take the square root of? Negative numbers. So your calculator, if you try this, would tell you error. Cannot take the square root . So what we're saying is that underneath the radical has to be what relative to 0? Can it equal 0? Is it okay to get 0? Yes. Can it be bigger than 0? Right, because if I plugged in like f of 5, my function is there. Yes? So we are saying, here's the key moment, we are saying x plus 5 has to be greater than or equal to 0. We're saying what is underneath the radical sign has to be greater than or equal to 0. Can we solve this for x? Yes? What would I do to solve this for x real quick? Say that one more time. Nope, we're solving. Let's try again. We're trying to get x by itself. So how would I solve this? Kind of helped you out a little bit right there. I've heard from both of these guys. Somebody else finish this up for me. Participate. Come on. Thank you, Cam. We're going to subtract 5 from both sides. Good. So what's my result going to be? Careful, not equals. Keep the inequality. If you look at these x values, is your graph backing up what you just found? Are my possible x values greater than or equal to -5? It's pretty cool. Matches, right? You solved and got x greater than or equal to -5, and your graph shows my possible x values being the same. So my domain for this graph would be all real numbers, x greater than or equal to -5, and I'm done. So on number 2, let's pretend on number 2 we don't have the graph. What piece of this am I going to pay attention to? Just what's underneath what? Yeah, just what's underneath the root. I'm going to take that and do what with it? What did you do over here? Set it what? X minus 2. How do I say this can be equal to 0 or bigger? Greater than or equal to 0. Let's find our domain. So it's just like I very carefully highlighted just what's underneath the radical, I'd recommend you do the same. Yes, very good. We're going to add 2 to both sides. I got x is greater than or equal to 2. Who got that? Good. How do I use that to write my domain? What do I say in words? How did it start? All real numbers, comma, what? X greater than or equal to 2. Fantastic. That's it. Does your graph back that up? Where's your first possible x value? 2. 2 and bigger or 2 and smaller? 2 and bigger. Is that what this is saying? 2 or bigger? Great job. Try the next one on your own. Try the next one on your own. Again, for all of these, we're going to pretend like you don't have the graph, just the equation. What am I going to pay attention to? Tell me that one more time. Yes, so for this one, what's underneath? Let's highlight that. What are we going to do with 2x minus 8? What do I do with it? I have to set up an equation first. I heard it. Greater than or equal to 0. Because again, what can we not have under the radical sign? What's not okay to have under the radical? Any negatives. So we're actually going to find the smallest x value. We're going to find this number. I know we see the number, but what if I didn't show you the graph? Go ahead and find it mathematically using your algebra. And then we'll compare answers. Yes. When we set greater than or equal to 0? Yes. Because underneath it, she's asking, is it always going to be a 0 right here? Great question. The answer is yes. Because I can take the square root of 0 and anything bigger than 0. And we represent that in math by saying greater than or equal to 0. Yes, Elijah? Yes, what'd you get? Fantastic. Does my graph back that up? What's my smallest x value? 4 and bigger. So all real numbers, x greater than or equal to 4, and I am done. That is my domain. Go ahead and try What's this? Number 4? Same process. Pay attention to what's underneath the radical only. What are we getting as an answer when we solve this? X is what? Does the inequality sign flip there? But the 12 is negative. Should it? When does the inequality sign change directions? Did I divide by a negative? No. So be careful with that. The top being negative, the numerator being negative does not matter. So this we're correct. All real numbers, x greater than or equal to -2. What's looking a little different about number 5 and 6? Well, yeah. So something must happen in your solving that's going to affect the direction of the graph. Go ahead for number 5 and 6. Pay attention. So Elijah, we're going to highlight what's underneath, and we're going to set it greater than or equal to what? Underneath. Take that piece, and what am I going to say this has to be? Not just 0, greater than or equal to 0, and solve. Go for it. What'd you get? I need you to start with x as the answer. A number is not an answer. I need an expression. Let me show you what I mean by that. Is this done? What do I need to divide by? Not -x. Try again. I'm going to divide by -1, and now the inequality sign does have to change direction. The inequality sign has to change direction here. Does the graph back that up? Look at that. Now you have a largest x value, right? And everything to the left. Is that exactly what this says? Less than or equal to? Fantastic. So only when we divide by a negative. But yes, so let's make our statement. What are those 3 words? All real numbers. Good. All real numbers. X. Fantastic. Go for number 6 on your own. Quite a few of us already have it done. I'm going to catch up to you. Everybody else, we're doing good. So questions like this are helping us to see the importance of keeping track of our negative signs. Because if we drop one, it could cause us some problems. Destiny, what'd you get as an answer for this one? Oh, you're still working. Jordan, what'd you get? So we're creating a little bit of a habit of giving me a number answer. I need an expression. Like here, the answer was x less than or equal to 4. The answer is not 4. The answer is x less than or equal to 4. Very good. Do you agree with him? But is this my answer for the domain? No. So we're going to write all real numbers x less than or equal to 1. Very good. Because we divided by a -3, the inequality sign, again, has to change direction. As soon as you divide by a negative, it has to change direction. And the graph of this function backs it up. Because look at what we got. We have a largest value of 1 and less. 1 and less. X less than or equal to 1. Fantastic. Let's make a connection to function notation. All of these are giving me what kind of values? X values. So let's plug them in. Go for it. So like f of 12 will be the square root of what? Yeah. And then keep going. Some of these may not exist. We'll see what exists and what doesn't exist. Does this first one exist? Yeah, what do I get? Ooh, careful. Square root of 16? 4. So that's good. That one works. Let's see what happens when you plug in these two. Oh, no, I'm pausing right here. What are you guys getting for the middle one? Good job. Is that okay? Okay. Good. Keep going. We're just plugging him in for X. What's happening on this last one? Is this okay? Why not? What's underneath? Negative. Does not exist. So from this, let's try to reason on why does a restriction have to exist. What is okay to have under a radical sign? An even root sign. What's okay? What's this? What kind of number is this? In general, positive. What's this? 0. So are positive numbers and 0 okay? What's not okay? So if we were to make this a sentence, why do we have to have a restriction? What can you not have? Can't take an even root. We got to be clear, right? Odd root was fine. An even root can't take an even root. Let's write with me, please. Can't take an even root of a negative number. We can't take, for example, square root of a negative number. Very good. Practice. So your homework is going to look just like the practice. So if we can do the practice, we can do the homework. Strategy. Let's write a strategy at the top. Strategy. Oops. Decide what does not. You let me know when I can keep going with this. Are we done? Thank you. Okay, strategy. Decide what does not have a restriction first. If it doesn't have a restriction, what's the domain? What's that symbol mean? Look at your warm-up. What's the domain for those? All real numbers. So some of these won't require any work. Does anybody see one on this sheet that does not require work? Number 2, All real numbers. What kind of function is this? Not linear. Look at the warm-up. I've got an exponent of a 2. What's that called? Quadratic. Quadratics. And from last year, do I have a positive a value or a negative a value? Meaning it opens. So this one's a quadratic. Definitely no restrictions. Okay. There's more on this sheet that have no restriction. Find me one. Why number 5? Number 5 is cubic? Linear. Very good. So all real numbers. Again, linear. Is this an increasing line or a decreasing line? I heard both. Try again. Increasing from left to right. There's one more on here. Remember, not all roots have restrictions. What kind of root does not? In general, cubic is what kind? Odd or even? Odd. Do you see an odd root on here? Look at your radical signs. Number 4, all real numbers. Odd root. I don't need the sketch, but I do want you to tell me that it's odd. So of these 5, how many of these actually require work? Only 2 of them. Now, what should I be highlighting? What am I only going to pay attention to in number 1? Just the x plus 7. Is that minus 3 underneath the radical? No. And in number 3, what am I going to pay attention to? Good. Just the 6 minus 2x. So let's work on those 2 right now. Let's find the domain of both of those, please. Yes, I can. You're welcome. Larry and Israel, it's attached. Okay? Yes. Royan, we're trying these right now. What inequality am I going to set up for number 1? Cameron or Royan, what am I setting up for number 1? Nope, one of these guys is going to answer. X plus 7, good, is what? Greater than or equal to 0. Write that down right now and solve. The reason why we write that has been the discussion of the day. We're saying that underneath a radical, it could be equal 0 or bigger than 0. It can't be negative. So this is how we figure out what x value would cause it to be negative. To solve this, what do I do? Great job. Now, this is going to be part of my answer, but what's my actual answer for the domain? All real numbers, x. Perfect. So let's look at this real quick, because I don't have a graph anymore, right? So check this out. Royan, to answer your question, watch what happens. If I plug in negative 7, like, right, equal to negative 7, what's negative 7 plus 7? 0. Can I take the square root of 0? Yes, I can. Give me something bigger than negative 7. 8. What's 8 plus 7? 8 plus 7. Careful. 15. Can I take the square root of 15? It'll be a decimal, but can I take the square root of 15? Yes, I can. What happens if I pick something less than negative? Give me something less than negative 7. A bigger negative. A bigger negative. Negative 10? What's negative 10 plus 7? Can I take the square root of negative 3? I cannot. So we have found what is it okay for x to be. Let's try one more here in the practice. What inequality am I going to set up for number 3? Jalen? Great job. Go for it. Yeah. Good job. got a couple people who said they're done. I'm going to check in with them to see what they got. I just heard from Jalen. Let's give Elijah a chance here. Elijah, what'd you get as an answer? Nice job. What did he remember to do? Why did he have to change that inequality sign? So my answer, though, because this is not done, what's my answer? Yep. Good job. So on tonight's homework, remember two things. Strategy. First, identify the ones that don't have a restriction, because those require no work, right? And then with your highlighter, using a highlighter to highlight what's just underneath the radical will help you to pay attention to it. Very good. Homework is on the back. I will be after school today till 3:30 for any grade sheet questions. After school today till 3:30, homework is on the back. This video will be up by 3 o'clock. Nice job today. Have a great day. If you borrowed a calculator, please put it back in the bin.